In this video, we're just going to go over trigonometry. So I want you to understand some of the basic things that are very, very important under the study of trigonometry. And I hope at the end of this video, you'll be able to answer multiple questions from this topic. Okay, so to start with, we are very much aware of what we call the trig ratios, which is also called SOHCAHTOA, right? Okay, so when we're dealing with trigonometry, we're trying to study the relation that is there between our shapes, of course triangles to be specific. So what relationship is there between the angle inside there and the sides? So that is what trigonometry is very much concerned about. Okay, so now the trig ratios apply to what we get to call the right angle triangle, a triangle in which you get to see a 90 degrees. Okay, so we call that the right angle triangle. So the side that is opposite to the right angle triangle, we call it the hypotenuse. It's the longest side in a triangle, in a right angle triangle. And then these other sides, one is called the opposite, depending on the angle that you're looking at. Okay, so let's say we're looking at this angle. That side on the other side is going to be referred to as the opposite, and then this side that is attached to this very angle is called the adjacent side. So that is where all our trig ratios are built on. So if we talk about sine, so the sine of that angle theta is given as the opposite over what? Over the hypotenuse. So this is all coming from this part. So everything else remains the same. If you go to the second trig ratio, it's going to be cosine of the angle theta. Now look at the adjacent side. So it says adjacent over hypotenuse. The other one is to be tan opposite over adjacent. So that can help you to get to find the angle theta in a case where we've given you the sides. You can also get to find one of the missing sides when you're given the angle theta. So we'll get to look at that a bit later. So I've just given you a review on your trig ratios that you are expected to know. Okay, another important aspect that we need to understand are what we call spatial angles. So spatial angles are the angles that you know the actual value. Okay, so for example, we do know that sine 30 is basically equivalent to what? To 0.5. So that's a spatial angle. This is a spatial angle because you know the result even without using what? A calculator. So what we can do is let's try to look at some of these triangles that can help us remember all these spatial angles. So I'll start with a 30, 60. Okay. So we have a 30, 60. So this would be our 90. And then I can consider this one to be our 30. And then this is 60. So of course you do know that if you get to add the angles in a triangle, you're supposed to add up to 180. So of course 30 plus 60 is 90. This is the right angle, which is also 90, which sums up to 180. Okay, so now the good part about this triangle is that you already know sine 30 is very common, so at least you can know it. Sine 30 is equal to 0.5, right? So 0.5 in terms of refraction can be given as what? 1 over 2. Now, if we go back to our trig ratios, we said SOHCAHTOA, right? The first thing that we had was dealing with sine. So we said it is what? Sine theta being equivalent to the opposite over the hypotenuse. So if we have sine 30 being equal to 1 over 2, it implies we have opposite over what? Over hypotenuse. So our opposite to 30 should be what? Should be a 1. So we'll put a 1 there. So the opposite to 30 should be a 1 according to the trig ratio. And then the hypotenuse should be a 2. And that becomes a 2. So this is the beauty about this triangle. Because if you know 30, you know the trig ratios, you'll be able to come up with the sizes of the sides. And then what about this other side? What can you do? You can use the Pythagoras theorem. Of course, you know the longest side. So the longest side, the square of the longest side, which is the hypotenuse, is equal to these other sides squared, the summation of the squares of the two adjacent sides. So let's say that is x. So assuming you don't know, that is 4, and we'll subtract 1 equal to x squared. So we'll get our value of root of 3. So that is how you can remember, in case you don't know the actual values, that's how you can remember this triangle. Now this triangle will help you understand a lot of things. So you already know sine 30 at least for the start. So we do know sine 30 is equal to 1 over 2. Okay, what else should we know? So now this 30, if we continue looking at our trig ratios, okay, and then we proceed to the next part, we've already dealt away with the sine, we can go to the cosine. So it's going to be cosine of 30. Now this one is interested in the adjacent side. So in this case, the side that is adjacent to the angle 30 is this other side, this side. Of course, when you're looking at the opposite and the adjacent, forget about the hypotenuse. So we're looking at that. So root of 3 is what? Is the adjacent side. So say it is root of 3. The hypotenuse remains 2. So we now know that cos 30 is equal to that. That's also a special angle. And then what else can we look at? We can change the angle. Or before even change the angle, we can still continue and look at tan 30. So tan 30, which is like the last part of the trig ratio, is equivalent to the opposite. The opposite is still 1, so it will be 1. And then over adjacent. So the adjacent is still root of 3. So these are the special angles in relation to 30. Okay. So you can use that triangle to help you remember all these. Very, very important and very applicable as you get to look at your equations, especially in assessments where they don't want you to use a calculator, or even a case where you are allowed to use a calculator but then they want you to simplify it or prove identities. You'd want to use these to work out your solutions. Okay, let's try to move. So I hope you've written down this. We'll now go to a different angle. So if we go to 60, you notice that sine 60 to start with. Of course, its opposite side is the root of 3. So we have root of 3. The hypotenuse still remains 2. Again, if we change, say sine, we'll go to cosine. Okay, so cosine is 60. So the adjacent side in this case to this angle is a 1. So it's 1. And then hypotenuse still remains to be a 2. And then tan 60 is going to be what? So the opposite is root of 3, and then the adjacent is a 1. So this is just that. Okay, so I'm sure you've noticed one thing. Sine 60 is basically equivalent to cos 30, right? And then sine 30 is equal to sine 60. So you can also know that to help you remember faster. Okay, so these are the major identities from this triangle. Of course, you can talk about 90 as well. Look at the angle 90 itself. So if you look at 90, the opposite is still the hypotenuse. So when you say sine 90, what's the opposite? The opposite is a 2 itself. And then what is the hypotenuse? Still a 2. So sine 90 is basically equivalent to a 1. What about if you say cos of 90? Cos 90 is equivalent to what? So this is a case where now you would want to confuse yourself a bit. Also, you understand when you look at the functions, because when you look at the functions, it will be very much easier, because you know, whenever you're talking about the cosine graph, this is the way it behaves, right? So if you're starting from 0 there, sine 0 is equal to a 1, sine 90 is equal to a 0, okay? And then that is sine 180, which is equal to negative 1, and then so this is cosine, and then cosine 360 of course is also going to be equal to a 1. 270 is going to be 0. So that will make more sense as we talk about the basic functions. But for now, we are done with this special triangle with special angles. We can go to a different one, 45. So this is a triangle where we have two sides having an angle 45. Okay, so let's put our hypotenuse to be down so that we have a right angle on top there. So these sides are going to be 45 and 45. Okay, so what we can do is let these sides be E1s, and then if you try to find the hypotenuse, what are you going to notice? You notice that the hypotenuse is going to be root of 2. Of course, we're saying 1 squared plus 1 squared is equal to hypotenuse, so you are going to find the root of 2 as your hypotenuse. Okay. So you've noticed that the angles are the same, and then even the sides are also the same. Now the hypotenuse is going to be the root of 2. So we can come up with special angles as well. So sine 30, sine 45, sorry. So if you look at sine 45, if you go back to your trig ratios, SOHCAHTOA, I'm sure you're able to remember that. So the first part is focusing on the opposite over the hypotenuse. So the opposite is the 1, the hypotenuse is root of 2. If you go to cos 45, the adjacent is still the same 1, and then the hypotenuse is also the same. So you notice that the opposite and the opposite and the adjacent in this 45-45 triangle are the same. So for this angle 45, the opposite is a 1, and then the adjacent is also a 1. So which makes it possible, we have this idea to say sine 45 and cos 45 are basically equivalent. Okay. And then what about if you talk about tan 45? So the fact that tan 45, the adjacent and of course we are talking about the opposite and the adjacent, they are the same. So we're going to have a 1. Tan 45 is basically equivalent to a 1. Okay, so these are the major ones that we can talk about under this triangle. So I just hope that now you know the major special angles. That will help us to simplify some of the equations. Okay, so even as we talk about referencing now, angle references, we need to understand the way the quadrants are. Okay, so we'll go to our quadrants. So what you need to understand is that in the first quadrant, all the angles that you get are using a calculator. So you can use a calculator or use special angles. All the special angles that we've talked about so far are in the first quadrant. Okay, so we do know 0, 90, 180, 270, and then 360 there. Okay. So all these are positive. So all angles are positive in the first quadrant. Whether you're looking at sine, cos, tan, they are all positive. Okay. And then in the second quadrant, only the sine functions are going to be positive. So all students take calculus. So that can help you remember. Okay. So all students take calculus. That can help you remember. So you can try this out. Try to get any angle between 90 and 180. Let's say 120. So sine 120. Try it with all the functions. Cos 120. Try it with tan 120. You notice that only sine 120 is going to be positive. All these others are going to give you negative answers. That's what we are trying to say. Now, if you try to get any angle between 0 and 90, and then try to use any of the three functions, you are going to notice that they are all going to be positives. Okay, they are all going to be positives. So we already demonstrated that using the special angles that we had, because they are all less than 90, so they were still giving us positives, and that's very, very important for us to understand. Okay, now with this in mind, we also need to understand that if you have this function, I'll start with an example. Let's say you have the angle sine x is equal to 0.5. So this angle x, you already know by now that the angle that you can put there to get 0.5 or 1/2, we can use special angles to do that. Of course, for the sake of understanding, what we get to do is we need to find, we call that finding the inverse of what we have the other side. You can use a calculator, but that is a special angle. No need of us using a calculator. We know that the angle x is basically equivalent to 30 degrees. Very important for us to understand. Okay. Now, hoping that you've understood that x is equal to 30, in that case, it can give us 1/2 or 0.5. I want you to understand that that is not the only solution. Sine, being a function, has got multiple solutions, a lot of values that you can put there to give you with 0.5. So, well, if we're trying to find a part where we're going to have a positive 0.5, we need to focus where? In the second quadrant, because we know in the second quadrant, that is where sine functions or sine angles are going to be positive, of course. Okay, So what we get to do is let's look at this. So the way we get to find our angles is we'll draw a line there. So we'll just say 180 minus 30. Okay, so I hope you get that. So the basic thing that we can say is whenever we're trying to find an angle in the second quadrant, we just subtract the angle in the first quadrant from what? From 180. That's a basic idea. So if you have 30 there, it implies that 180 minus 30, which is basically going to be equivalent to 150, is also a solution. You can grab your calculator and try that. Sine 150 is also going to give you 0.5 or 1 over 2, which is true. Okay, very important for you to understand that. Now, what about if I change it? Let's say I go to cos, and then I say cos, let me use something different. Let's say x, and then is equal to 30. So now in this case, you will realize now the importance of us knowing the special angles. Okay? So we say the special angles, what value of x can give us. What have I put on the other side? I'm not supposed to put a 30 there. I'm supposed to put 0.5. Sorry. Okay, sorry for that. So what are we supposed to put wherever is x to get 0.5? So I've already even given you an idea on what you're supposed to do. So obviously the value of x will be what? So if you go to the special angles, it will be 60, because we said cos 60 and sine 30 are basically one and the same. Okay, and I hope you are still able to remember the 30-60 triangle to help you remember that special angle. Now, when they give you such a question to say find the value of x, they don't just expect you to find one result. Of course, they're going to even give you the range. Let's say they ask you to say between 0 and 360, find the value of x. So they can say find the values of x. So the second result, you're supposed to understand where do you expect cosine to be positive, because the other side is a positive 0.5. So you need to ask yourself. So you realize that we are talking about what? The fourth quadrant. Now in the fourth quadrant, what you get to do for you to find the angle is you subtract from 360. So it's 360 minus the angle in the first quadrant. And then just to add more, in the third quadrant, we add to 180. So very easy. Never should you think of using 90 and 270. We only use the angles along the x-axis. So if is it before 180, you subtract. Is it after 180, you add. Is it before 360, you subtract. Okay. So that is the easiest way you can remember when you're dealing with a case where you want to find the other solutions to your question. Okay. So that is what you get to do. So in this case, 360 minus 60 is also going to give you 300. So if you grab your calculator, cos 300 is also going to give you 1 over 2 or 0.5. That is the way it gets to work. Now, let's look at something different. What about if you say it's sine x is equal to negative 0.5? So I can also say negative 1 over 2. So now, look at this. It's a negative. Did we talk about special angles that are negative? Of course we didn't. But what we know is, let's try to assume to say we're trying to find the value of x when we have a positive result on the right hand side. So we'll say our possible result if we had a positive 0.5 was going to be obviously 30, because we know sine 30 is equal to 0.5. Now, notice that in this question, they want a value that can give us a negative 0.5. And now let's say they want an answer between 0 and, let's say, 360. So going back to our quadrants, we said all students take calculus, right? So in which quadrant are you able to see that sine is going to be negative? Since we said in the first quadrant all of them are positive, in the second quadrant sine is positive, so obviously it's going to be negative in the other quadrants where tan and cosine are expected to be positives. So therefore, what should we do? We said for you to find the angle in the third quadrant, you get to add to 180. And then in the fourth quadrant, subtract from 360. So therefore, possible results of values of x are going to be 180 plus 30, 360 minus 30. So we have 180 plus 30. What do you expect to have? 210. And then 360, that is 330. So these are the values of x, two values of x. Don't present this one as an answer because it's going to give you a positive. So you are just using it to help you find the answers. Because we use reference angles, we use the angles between 0 and 90, which are always positive, to help us find the required results. But in a case where they wanted us to find for positive 0.5, you would agree with me that 30 would also be an answer. But in this case, we've just used it to find the answers to the other parts where we expect sine to be negative. So the same applies to cosine, to tangent, and yeah, so the same applies. So that is the way you get with references of angles. Okay. Now let me just try to show you the way you get to convert between radians and of course degrees. Okay. So you do know that when you think of these quadrants in terms of the radians, so 0, so that is pi over 2, and this is pi. So how about 270? Let's say you don't know 270. So one thing that I use myself to help me understand, because initially when learning my angles, I started first of all by dealing with angles. I came to learn about radians a bit later. So this used to help me. Understanding that pi is basically equivalent to 180 is something that will help you out. So in a case where you want to convert 90, let's say 90, what you just want to do is always just divide by 180. Or let me just say multiply by pi over 180. So you get to understand that this is going to give you 90 into a 90 itself is going to give you a 1, and then you have a 2. So pi over 2. And then what about 270? So 270, all the same, we just divide by 180 and then add a pi. Find the ratio. This can divide. 27 can be divided by 9 3 times, 2 times. So this gives us 3 pi over 2 for 270. For 360, of course, we just know we are doubling the pi to give us 360, so it becomes 2 pi. So that is the basic or the easiest way to convert from radians, from degrees to radians. How about from radians? So when you're moving from radians, all you can just do is now just substitute at the point where you have pi, put 180. So for example, 3 pi over 2, we can just substitute where there's pi, and then we can put 180. So that is going to be 90 by 3, which will give you 270. So that's how you convert between radians and also degrees. Okay, so I've got some more videos that you can watch under trigonometry, under sketching, double angles, solving trigonometric equations, identities, and also solutions to the tutorial sheet for UNZA students as well. You can have access to that if you register. So in the description there's a link to the platform that will allow you to register. So on that platform you'll be able to access all these videos and many other topics like binomial expansions, calculus, and matrices. Okay, of course including all the topics that you did in your first semester. So anyway, thank you very much for watching, and have a lovely day.